Hello, Period 8. I'm Lucas.
And I'm Max.
And for the past month, we've been doing an independent study about all the ways that the universe could end.
Yeah, so these are some pretty advanced physics concepts, so we've boiled it down to just what it is in a nutshell.
Mm-hmm. And keep in mind that this is ways that the entire universe, not just life on Earth, could end.
This is a lot of big stuff just blowing up.
It is. It's very existential, very negative, very hard to get over once you really start thinking about it. So let's do that.
Yeah.
First up is vacuum decay. The first thing you need to know about before learning more about this theory is that some objects possess high energy levels and some possess low energy levels. Because the universe craves entropy and stability, high energy objects are compelled to low energy levels by quantum fields, which are essentially the laws of physics. When quantum fields become stable, they reach a vacuum state. Don't confuse this with the vacuum of space. They're separate things, it's just that scientists aren't always the best at naming things. The next thing you need to know about before learning about vacuum decay is the Higgs field. First conceptualized in 1964 by Peter Higgs. Oh my god, look at him stick his little head through the curtains. He's a particle floating around the Higgs field. I love it. First conceptualized in 1964 by Peter Higgs, the Higgs field is found everywhere in space and gives particles their current mass. For the purposes of the theory, mass is defined more closely to inertia. It's a force that makes objects resist movement, and Higgs argued that if inertia is provided entirely by a field in space instead of the inherent properties of the particles, then their smooth interactions in space can be easily explained. Another cool thing about the Higgs field is that it could theoretically produce the Higgs boson, a small particle with the same properties of the Higgs field. If two subatomic particles collided, the force created could dispel some of the Higgs field surrounding them, creating the Higgs boson. This remained a theoretical concept until 2012, when the Large Hadron Collider found experimental results fairly consistent with the Higgs field. The stability of the Higgs field is vital to the stability of our universe. If it was revealed that the Higgs field was metastable, only appearing to be stable without actually being stable, the universe would be in a lot of trouble. By trying to move to a lower overall energy level, the Higgs field could release an enormous amount of potential energy, and this would destroy everything as we know it in a phenomenon called vacuum decay. Space would be altered around the area where the vacuum decay started, and as the release of energy would expand circularly at light speed, everything would be destroyed as it came into contact with a black hole. Vacuum decay would take a fraction of a second to redefine the laws of physics by taking out everything we know about the universe. And as everything could eventually become consumed by this ever-expanding black hole, the universe would just have to start over at some point. This produces good news and bad news. The good news is that the expansion of the universe might counteract the movement of vacuum decay and it might never reach Earth. In this scenario, the vacuum decay would try to approach the Earth by running on the equivalent of a cosmic treadmill. The universe's expansion would stop it from doing so and effectively keep it the same distance away from us. Or by the time vacuum decay would reach Earth, humans could be extinct, so it's not really our problem. The bad news is that vacuum decay could begin anywhere, and if it begins close to Earth, we as a planet are finished.
As you probably know, the universe is expanding. This pulls matter apart. However, matter is currently kept together by a little thing you might have heard of called gravity. However, the Big Rip theory states that as the expansion of the universe, and thus the space between objects, increases, the universe could be ripped apart. First, galaxy clusters would part and become just galaxies floating around, and then individual solar systems, then individual stars and planets, then individual atoms. And the universe would be expanding faster than the speed of light, so particles could never touch, and they would just be lonely and floating around forever. Another Big Bang could theoretically occur through quantum tunneling, but it could take trillions of years. In opposition to the Big Rip, the Big Crunch theory states that the universe could at some point stop expanding and gravity becomes the leading force in the universe. The universe's expansion would stop and reverse, causing objects to come closer together and collide. The background radiation of the universe would increase as it becomes smaller due to the increasing density of the universe. The radiation would make it nice and toasty, too toasty for life. Eventually, all objects would collide and make a super-uber black hole that eats the entire universe and then itself, which causes a new Big Bang to occur and the universe to restart and begin anew. The theory states that this has happened a lot of times and that it is a never-ending cycle of the universe.
Cool, so on that note, we hope you guys enjoyed the video. We had a lot of fun making it, and we hope you had fun watching it.
Yeah, even if you have some mild existential dread, you'll get over it eventually, just like I did.
Exactly. All these processes would take thousands of years to occur, so by the time they reach Earth, the human species might already be extinct. So don't worry about it.
Yeah,
we'll
die way sooner than any of this actually happens, so
Happy
okay.
Monday!
If it was revealed that the Higgs field was Cool, awesome, you're the best. That's gonna be a blooper.